On this one, we're using the quotient rule together with the formula for the derivative of a secant function. So if you recall, the derivative of the secant function turned out to be secant multiplied by tangent, so secant x tangent x. So if I get y prime, it's a quotient of two functions. I differentiate the top function, and I get secant x tangent x. I leave the bottom function alone, so multiply by x squared, subtract what you get by leaving the top function alone, multiplying by the derivative of the bottom function, and then divide that whole thing by the square of the denominator, so we get x to the fourth out of that. Okay, there's not a lot that you could do. We could factor out an x to simplify things a little bit before we actually substitute x equals pi, so I suppose I'll do that. So 1x has been factored out of the numerator and then canceled out with one of the ones from the denominator. So I have x secant x tangent x minus 2 secant x all divided by x cubed. And then I want to evaluate y prime at x equals pi. So I end up with pi secant pi tangent pi minus 2 secant pi over pi cubed. We'll just go ahead and go up here. So you have to think about the unit circle and the angle of pi, which would point directly to the left. And the tangent of that angle is 0 because the y-coordinate of that point is 0. So this entire term is going to die because it's being multiplied by 0. And then secant pi, that's 1 over the cosine of pi. But the cosine of pi is -1, so the secant of pi is 1 divided by -1, which is -1. All right, so secant pi times 2 is actually positive 2. And then a pi cubed in the denominator. And there's my answer.